All right, Mr. Rops here.
Mr. Cole.
And we've been talking about solving simultaneous equations, or if you're American or Canadian, you call them systems of equations. And we've narrowed it down that we have three main methods. The first method is a graphical approach. The second method is substitution. And the third method is elimination. And sometimes, depending upon what you are given, one method is more appropriate than the other.
They should always all work, shouldn't they?
They will always all work. And actually, the best or the easiest method, the one that always works, is to use your graphing calculator. Graphing calculator.
The polysymulta.
Polysmult.
That's a good one to check with.
Yeah, it's a great one to check with. So all of them will do this one, but we're going to talk about more of an algebraic approach. If we want a graphical approach, it's easiest if we have like a y equals something set up and a y equals something set up. Already set in y equals mx plus b. You pound it in, you punch out the number. Yep. The disadvantage of this, though, is if it's not a nice coordinate and you don't graph it accurately, you're not going to find the solution. So it's really almost a better means just to get a good sense to estimate what your points are.
Yeah.
Okay. The biggest two to think the difference are these two. And I like to use substitution if one of my coefficients, so if I had this equation, one of my coefficients has the number 1 in front of it, then substitution would work.
It'd be easy to get it on its own, wouldn't it?
Right, exactly, because if I had this, I could easily solve for y and plug it in. If it's a 2 here, it's hard to solve for one of these variables all by itself. Then you have fractions and it gets really messy. If this was the situation, then I would use elimination.
Okay.
All right, so let's take a look at a couple examples here. Here is the first one. We want to see which method would work nicely. What are our choices, Mr. Cole? What would you do?
Well, that'll work, obviously. But I think with the first one, just having one y on its own, I would set that, so I'd do y equals 2 minus 5x, and I would substitute that into the second equation.
All right, so substitution would go here.
Yep.
Okay. Elimination would work as well, but substitution is probably...
They all work.
It's quicker and easier. Okay, this one. What would you do for this one?
I think if you just look at the graph, because they're both y equals, and actually you'll spot something very quickly. Should we just solve this one now?
All right.
Or do you want to come back to it?
We can do it really quick. First one, y-intercept is 1.
Yep.
And
gradient is 2. So
up 2 over 1. And I go, here's the line.
Yep.
That's this one. I'll switch to pink for the other one. Again, I go up y-intercept of 1. Uh-oh. That's a good thing. 1, 2, 3 over 1. I can see really quickly that there, the point 0, 1, is the solution. That's where they intersect.
Okay, so it's worth looking at the graphical method just to see if you can do it really quick and easy. All right. This one, definitely elimination, I think, for this one.
All these coefficients cannot be changed to 1 easily without getting fractions. So definitely elimination.
Substitution works, but you'll be substituting fractions and it gets messy.
Very messy substitution. And actually, elimination is by far my preferred method.
Yeah.
Well,
I like it.
Polysmult is my preferred, but
I think it's clever.
If I have to do it, I like that one. And, last one.
You could, anything would work here, but substitution would be fairly straightforward.
A substitution is quick and easy, but also elimination, because I just multiply by negative, they cancel away really nicely as well. So there's really no best method for this one. They're both quite straightforward to do. No tricks. Good luck.